Hello, my name is Anthony Shivkumar, and in today's video, I'm going to talk about the different tools I tend to use when I'm working with embedded systems. What do I mean by that? Now, you might have, say, different devices that you want to test. In this particular case, you might want to test, say, a motor play driver, or you want to test, say, an analog to digital converter with which is high precision, or you want to test, say, an LCD device, or an LED that requires some form of communication in order for it to change colors, or an IMU unit such as a gyroscope or an accelerometer. And how do you interface with these devices? Some of them are custom made by me. Some of them you buy from say SparkFun. But how do you interface with each of these devices? And that's the real topic for today. So generally what most, a traditional way of interfacing is, and especially if you can get the code, a source code for, is to, use your Arduino. And an Arduino generally, has a rich library, and it allows you to, to interface with most devices, including, say, in this particular case, a GPS or an accelerometer. But what about when you start to create your own custom device, like this pre-driver that I'm going to be using for my drone? And then you realize, you might have to write your own source code, and you need to understand some form of algorithms, and it might be, it might not be necessarily easy, and you probably, might be limited by just, utilizing just open source projects. And I firmly believe that you should have you should have both, not just what's out there, which is like an open source project, but it's also good to have your own custom development board. And in this particular case, I have something called as the LPC1769, which is fabricated onto my own custom board over here. And this is the programmer that programs the board. And I also have another one, which is called the KV5X from NXP, which is a little bit more advanced processor. And both these devices will allow me to design my own custom board and program them. So in order for you to work with embedded systems and have a good rich tool set and communicate with peripherals, sensors or accessories or whatever be it, having a device that has a rich library, and also starting to create your own devices and blending more towards this type of custom development really allows you to get and become a master of embedded systems rather than just being a beginner. And don't get me wrong, you can do a lot with Arduino. There are very cool projects and very sophisticated projects that you can do with this. But when it comes to say development of something that's beyond the Arduino library, and you want to say use more advanced processors or advanced chips, or create your own custom understanding of certain things, maybe you're designing, say in this particular case, a more advanced drone, and you realize, say, the current capabilities is nice, but you found a better way of solving a problem, and you don't necessarily think that the library that's out there is as good as what you have come up with. So developing your own custom board, for the most part, can really benefit you. And also, not to mention, it's fun. You learn electronics, and just getting things running and working is also great. It just gets you excited, and it also gives you superpower, because now you're not just limited by what's out there. You're now limited by your creativity. So when it comes to having your own embedded toolkit, I generally feel having a couple of custom boards. So this is the KV5X, this is the NXP in 1769. This is the programmer that programs the board, and you have an Arduino. In this particular case, I also have another development board by Nordic Semi, which is which allows me to do radio communication. So I do have a couple of off-the-shelf development boards, and I also have all custom development boards. And so when it comes to different peripherals, I have the ability to see which one I want to test the code very quickly to get the system working, and then I translate some of that code into my custom board if I'm deploying this onto a custom hardware or to a new design that I'm currently working on. And that's my embedded toolkit in a nutshell. So you need to have a programmer that can program your custom board. It's always good to have a development board, especially if you're dealing with certain things. For me specifically, if I'm dealing with drones, these are the 6 to 7 peripherals that I always would need. One of them being, say, an accelerometer or and a gyroscope for my IMU measurements. So having a chip that allows me to to measure the orientation is very critical. A GPS may be or may not be necessary depending on the more advanced features that I want to implement. But in the beginning, if I'm testing just purely flight control and flight dynamics, it's very important for me to have a accelerometer and a gyroscope. I also need to have a motor controller. Now, you might be able to use off-the-shelf motor controllers. In my particular case, I've designed my own pre-driver, and I'll be using this pre-driver to control my to control my brushless DC motor. This allows me to do a lot more interesting things in terms of getting feedback, understanding my feedback, measuring and controlling the power and voltage, and it also allows me to write the algorithm that is it's much more efficient and more optimized for the processor that I'm using compared to some off-the-shelf algorithm. So I also have, like, say, another USB to SPI, so I can plug it in and communicate with any device that has SPI. I'm creating one for I2C. I'm creating one for UART and the other embedded protocols. So I can just plug it in, put some code on my computer, or just write a small little script on my computer, and I can start to send the signal and start communicating with other peripheral devices. In this particular case, an analog to digital converter, which is 24-bit. So this is what I generally feel is a good embedded library, especially when you are moving more from the beginner stage to more advanced stage, or rather intermediate stage, where you are playing around with not just what's out there, but also playing around with what you want to create and create more, and have that ability and flexibility of not just being restricted by what's out there, but also by your creativity and exploring that. So that's really the way I look at an embedded toolkit. In terms of not what you have, but what and more importantly is how you can exercise your creativity in ways that is not just what's out there, but it's also more in your technical capabilities, in your unique designs and approaches, and really taking your designs to the next level and taking your applications to the next level. Having a combination of this type of setup really helps you go a long way, in my opinion. I firmly believe that if you could build everything from the grounds up, you should, because you learn so much to a point where if anybody asks you a question, you'll know in and out of what's going on to the system. But not everybody has the time and energy, and sometimes it's an aptitude as well. And that's where buying a development board like an Arduino it will suffice perfectly. And there's nothing wrong with that. So having said that, depending on where you are in your journey, if you're at the beginner stage, stick with Arduino. There's nothing wrong with it. But as you cultivate and develop your skills and want to move to a more intermediate level of actually developing these boards and becoming more having more ownership of what you're building, highly recommend start creating your development boards, your own custom boards, and integrate all of them together in terms of use this to prototype something quickly, and use this for advanced development, advanced prototyping, and advanced deployment. That's my embedded toolkit in a nutshell. Creating my own boards with a combination of what's out there. And thank you so much for listening. If you like these videos, I highly recommend you subscribe to them, and if you like it, do like it. That thumbs up would go a long way for me, and thank you so much.